Comprehensive Code YouTube channel. Today we'll be solving Leetcode 3068. Find the maximum sum of node values. Let's read the question and understand it. There exists an undirected graph or tree with n nodes numbered from 0 to n minus 1. You are given 0 index 2D integer array ages of length n minus 1 where age I equal to vi ui vi indicates that there is an age between ui and vi in the tree. You are also given a positive integer k, a zero indexed array of non-negative integers norms of length n, where norms I represents the value of node numbered I at I. Alice wants the sum of values of tree's nodes to be maximum, for which Alice can perform the following operation any number of times, including 0, on the tree. Okay. Choose any node uv connecting the nodes u and v and update their values as follows. Norms u equal to norms u jor k, norms v equal to norms v jor k. Return the maximum possible sum of the values Alice can achieve by performing the operation any number of times. All right, let's take this example 0 1 2. So there are three nodes, okay, and the values of these three nodes is the value of 0th node is 1, and the value of first node is 2, and then the value of second node is 1. Okay, all right, so now let's see. To solve this problem, we have to understand fundamental bitwise JAR operation, what happens in JAR operation. Okay, let's take one example, 1 0 1. Okay, and then another number is, for example, 0 1 0. Okay, applying JAR on this, for example, this one is A and this one is B. Okay, applying JAR on this, for example, if you do A JAR B, then what happens? The result is if the bits are same or opposite, it will be 1. Okay, if the bits are opposite, no matter what, it will be 1. And if the bits are same, for example, like this, then it will be 0. Okay. All right, with that, let's see. The number, while we do this JAR operation, the number can either decrease or increase. In this case, it is increased. However, if we have something like this here, it will decrease, right? So that is the fundamental thing that we need to understand here. So we are given these numbers. So these numbers are the weights in the nodes, right? So when we iterate over these numbers and we do JAR operation, if the number increased, that means the maximum sum value can be increased taking that node. But if it decreases, then the maximum value we are trying to maximize will decrease. So we don't have to include that node which is decreasing the value. Okay, so, and that value which is decreasing the value, that should be minimum to maximize it. I think it is a little bit unclear now, but when we start coding, it will be very clear. With that, let's begin coding. Okay, so as I said earlier, we'll track some total sum. Okay, let's say as 0 for that, and then the count is 0. We need to track count because if the number of nodes that we're taking as positive, that means they are the pair. There exists a pair. But if the number of nodes we are taking is odd, that means if we are taking 3 nodes, for example, that means one doesn't have a pair. In that case, we have to decrease the minimum number so that the total value or total sum can be maximized. All right, so that let's also initialize positive minimum. Minimum is float, and let's say this as infinity, okay? And negative maximum is float minus infinity, okay? Now let's iterate through node value, okay, in our norms, okay? Node value after JOR operation, okay? That is basically node value JOR k, right? And we said like this value can either be positive or negative, okay? So also let's sum of that equal to node value, okay? And what is the net change? Net change is node after value operation minus node value, okay? This net change can either be positive or negative, right? As we said earlier, if net change is positive, okay, if it's greater than 0, then positive minimum is the minimum of positive minimum and net change, okay? And then total sum, we need to add the net change here because we have to include this net change if that is the positive, okay? And then we also need to increase the number of counts here. But if it is not, if the net change is negative or 0, we just do negative maximum is maximum of the negative maximum and net change, okay? Now at last, like, we'll check if this count is even. If the count is even, that means like there are pairs. There are pairs forming this total sum or maximizing that total sum, okay? If the count is even, we just return total sum, okay? But if it is not, then what we have to return is the maximum of the contribution of the positive total sum minus the positive minimum, okay, and total sum plus the negative maximum, okay? So basically, if the number of nodes like that is increasing is odd, then we have to negate the contribution that has been made here and take the maximum of the contribution that has been done by this negative maximum and positive minimum. I hope that makes sense, and let's run this code if it is good. So as you can see, it passes through these three test cases, and let's submit this. As you can see, this is pretty efficient and passed all the test cases. If you find this helpful, please just subscribe me in my YouTube channel. I'll be bringing more videos in future. And if you are confused, just let me something in the comment below about what you are confused. I'll reply you as soon as possible. Again, thank you for listening and watching this video. Hope we'll meet soon in the future. Thank you.